products like Nemo and Smart Things, and Nest is making a bid for being the orchestrator of smart home products. Well, in this near future, ProtectServe, which is a sample application, what's that?
Demolition.
Thank you. Yes, it is. ProtectServe is the original name of UMA, in fact. So ProtectServe is our near future hypothetical smart home orchestrator, willing to be your sharing management hub. And the reason it's better is because it's UMA enabled, which means that whatever the manufacturer of the products that hook up to it, smart home devices, the IoT services, and so on, they just have to be UMA enabled. And so Angela, our homeowner, and her young son Zachary, they live in a home, just the two of them alone, and she initially got attracted to smart home devices because she wants to be secure in the home with the young son. And so at first she bought the smoke detector made by iSpy and the video doorbell made by iSpy, but she soon kind of got hooked and she bought a coffee maker and a TV streaming device. And before she knew it, she had them all hooked up very easily because even though they were made by different manufacturers, iSpy, iAwake, and iSee, they could all be hooked into ProtectServe pretty easily. And you can see the benefits of managing them and managing sharing of access by others to them from a single place. Now, this is an implementation based on OpenUMA, which is the open source project run by my company, ForgeRock, but it's a standard, so lots of people are implementing to it. And so you see a kind of aggregate resources view, and UMA calls these resources generically. They can be documents, they can be API endpoints, they can be devices. And so in this case, you're seeing a series of devices whose cloud services are hosted by many different manufacturers. If you have a panic moment, you realize something is wrong, you can unshare them all at once. You can label them yourself. In this case, the systems themselves have provided some labels. You can star the ones you want access to frequently. You can even filter down if you want to see the ones that have spy in the name, you can. But where it gets really interesting is when you want to share access. We know from OAuth, you can decide to consent to access by applications that you yourself are using when you authenticate in at that moment to do so. But the point of UMA is to share access to other parties with whom you do not share credentials. So for example,
just to kill me if I didn't to point out that OAuth is not an authentication system.
No, but you do have to authenticate in order to authorize access to the client application you use. You look at every one of the swim lanes in RFC 6749 and you see authenticate and then authorize.
Just channeling Justin.
Yes, no, but you can channel Justin all you want. It's not an authentication protocol, but guess what you have to do first before you authorize. The smoke detector, Angela has actually shared access with her house sitter, Eric. So she shares access with Eric because she goes away with her young son, and she's security conscious. But Eric moved away, more's the pity. So she decides to give access to her new house sitter, Britney Spears, as it happens. So she takes the opportunity while she's giving access to Britney to trash Eric's access, which she can do from a single place because ProtectServe. And here she can add Britney's mail.com. And here we see the power of constrained delegated access to other people. She can add whatever scopes, here we call them permissions nicely, to the functions that are important for Britney to have. Now, what's interesting to see when you look at the TV streamer device, she's already given interestingly constrained delegated access. Eric's got to go. Zachary has access to the child-safe programs. Well, Britney can have access to those, sure, and to the regular programs, but not to the XXX ones. That would be inappropriate when Angela is paying her. So that's set up. Finally, I just want to show you the money one, video spy bell. So we got to get rid of Eric again, but we want to make sure that Britney has access to this very important security function. Yes, to view what the camera shows. Yes, to move the camera side to side, but not to be able to disable the camera, because that's reserved to Angela alone. And when she's on the road, she wants to see who's at the door too. So I want to go be Brittany for a moment, and then I will turn the demoing over to somebody else. I'm going to go be Brittany at the iSpy mobile-friendly application. So Brittany is a house sitter for a lot of people in the neighborhood. And iSpy happens to use a federated pattern for login, and it lets you use your local ProtectServe login, which Brittany has. Now, it could have also enabled her to log in through further federation of Gmail, for example, would be another possibility, or other patterns as well, but that's the one that it picked. So she logs in to get started using iSpy. And the first thing it wants to ask her is, the most important thing to note here is, allow the application to seek authorization for access to resources controlled by others on your behalf. This is an OAuth pattern. This is an embedded OAuth pattern that UMA uses in the protocol.
That's hard to parse.
Yeah, you can make the wording whatever you want. We wanted it to be accurate. And by the way, this is an OAuth flow that could be sort of optimized and embedded in certain kinds of flows that she doesn't even see it. And you can make it very long-lived, so she only ever sees it once if you do want to expose it to her. Basically, this is the rule of access control. If you want to get access to somebody's stuff and their policy says, I need to know your view before sharing it, well, that's revealing who you are. And so we're asking Brittany to consent. So she consents to that. Therefore, she's allowed to maybe possibly see Angela's doorbell. She goes and looks at Angela's doorbell in 2 seconds. So she gets a view of the camera. She has the scope to move the camera. We've decided to build in this sample application. Well, she can't, we know she can't control turning the camera off, but she can request access. Angela, who's on the road, this is value add we built into our UMA-enabled application, gets a pending request, which is, yes, there it is, aggregated into a single location. Now this is interesting because she still doesn't want to allow Brittany access, but she has not perturbed the access that Brittany already has. Camera view, camera version. So what she's done is selective, constrained denial, or withdrawal of access to Brittany, to a different party. So that's my few minutes on UMA and the OpenUMA value add. And that's just the power of having a protocol that's wide ecosystem.